In this project, we reimagine Murabaha and Sukuk on blockchain. You'll see how smart contracts can encode Sharia rules, track ownership in real time, and give regulators and investors transparent, tamper-evident records across the entire product lifecycle. Vision 2030 isn't only about new buildings, it's about reshaping Islamic finance. Imagine PhD research that directly influences Saudi Arabia's digital Islamic economy. That's the level of impact this course is designed to help you reach. Murabaha and Sukuk are both asset-backed, but they behave differently. In Murabaha, the bank buys a real asset, then sells it to the client at a marked-up price paid later. That's cost-plus financing, not a loan. In Sukuk, investors fund a project through an SPV and receive certificates that represent real ownership shares, not interest-bearing debt. Across both, Sharia requires no riba, no excessive uncertainty, and transparent tracking of the underlying asset throughout its lifecycle. In Saudi Islamic finance, legacy systems create exactly the kind of research gap PhD work should tackle. Data are scattered across banks, SAMA, and exchanges. Reconciliation is slow and costly. For Sharia auditors, ownership chains are hard to see end-to-end, making real-time compliance verification extremely challenging. Here, blockchain acts as a specialized trust layer for Islamic finance. Immutability locks every contract action into a tamper-evident log, so Sharia boards can audit decisions with confidence. Tokenization links each digital token to a specific asset or cash flow. Smart contracts then automate profit sharing and payment schedules, reducing manual errors while enforcing predefined Sharia constraints. In this design, we assume a permissioned blockchain, not a public one. Only authorized entities participate: banks, issuers, and the regulator. The regulator runs a supervising node and enforces consortium governance rules. Privacy is handled so each transaction is visible only to the relevant parties, yet still auditable. Compliance checks like KYC and AML are built directly into the protocol and smart contracts. Now we contrast two tokenization choices. A Murabaha token links the receivable to a specific asset and its state. Because it's tied to a debt-like obligation, you typically keep it non-transferable to avoid Bay al-Dain issues. A Sukuk token instead represents fractional ownership in an underlying project, so it can be fungible, tradable, and economically closer to equity. Murabaha is still a cost-plus sale, but the smart contract enforces its Sharia sequence. First, the bank and client agree on terms and price. Next, the bank acquires the asset and records ownership on-chain. Only then can it sell to the client with an agreed markup. Deferred installments are logged as they're paid. The key principle: no sale before on-chain proof of ownership. For Sukuk, the asset is the economic core. At issuance, smart contracts mint tokens that represent fractional ownership of that asset, based on a Sharia-compliant valuation. As the asset generates cash flows, profit distribution runs automatically. Those tokens can be traded in secondary markets, with every transfer recorded on-chain. At redemption, tokens are burned and investors receive their principal. Smart contracts are powerful, but they're blind without trusted data. Oracles act as bridges, moving information between the blockchain and external systems. For Saudi fintech or regtech projects, that means safely pulling in CYBOR benchmarks, verified legal documents on IPFS, and government-backed digital identities like Abshir, then exposing them to your application layer through well-governed APIs. This leads to a core benefit: a blockchain-powered, Sharia-aware audit trail. Every Sukuk or Murabaha action is logged immutably. Regulators get live, RAID-only oversight. Sharia boards see automated asset existence checks. Compliance reports are no longer assembled manually. They're generated on demand from the ledger. Think of the implementation roadmap as a way to de-risk your research. First, in the design and proof of concept phase, you fix requirements, encode them in smart contracts, and test assumptions on a local ledger. Next, the sandbox phase lets you integrate with partners and SAMA-style environments in a controlled way. Only after that do you move to a limited, tightly monitored production pilot. When you design a PhD prototype, you must define success in both technical and business terms. On the technical side, you measure throughput in transactions per second, the cost of each operation, and whether your security assumptions still hold under attack. On the business side, you ask whether settlement times dropped from days to minutes, audit accuracy improved, and reconciliation errors were materially reduced. Across this module, we started from a clear pain point: opaque Murabaha and Sukuk life cycles that are hard to audit for Sharia compliance. You then designed a permissioned blockchain with smart contracts, using design science research, prototyping, and sandbox testing to support a transparent digital Islamic economy aligned with Vision 2030. Now it's your turn. Which project idea do you think could genuinely shape the future of Islamic digital banking in Saudi Arabia? Share your concepts, critiques, or new angles, and we'll refine these blueprints together.